We've all been there, right? You sit down, you grind through a textbook for 3 grueling hours, close the cover, and suddenly realize you remember absolutely nothing. It's incredibly frustrating. You basically fell for what's called the illusion of competence. You put in the time, so you just assumed the learning was happening. Well, in this explainer, we're going to look at the hard data. Because cognitive science consistently shows us that how you read matters vastly more than how long you read.
Okay, let's jump right in by debunking the most common ineffective study habits that so many of us rely on. I'm talking about rereading the same chapter multiple times, highlighting basically everything on the page, copying your notes word for word, cramming the night before an exam, and studying for hours without ever testing yourself. Research has actually found these habits are much, much less effective than active learning. They just create a false feeling of familiarity. You look at the text and think, oh yeah, I know this, but you aren't producing any durable learning.
So, how do we fix it? Here's our roadmap for today. First, we'll cover the passive reading trap. Second, preparing your brain. Third, the Feynman technique. Fourth, active recall and spacing. And finally, the 45-minute master plan. Now, what's really interesting is that we're actively applying the science of schema activation right now. By giving your brain this mental framework of the explainer ahead, we're creating mental hooks for the new information coming up.
All right, Section 1, the passive reading trap. Let's see why simply reading from beginning to end is literally one of the least effective methods for long-term learning.
This right here brilliantly illustrates the stark difference. The passive reading trap, where you just let your eyes kind of wash over the page, maybe dragging a highlighter along, totally overloads your working memory. Your brain can only hold a very limited amount of information at once before it just drops it. Durable learning, on the other hand, that requires effort. It requires active recall, self-testing, and spacing out your sessions. You really have to actively process the text, not just consume it.
Moving on to Section 2, preparing your brain. Now that we know what to avoid, let's look at how to prime your mind before you even read a single paragraph.
When you sit down to study, you need to engage in what scientists call schema activation. Research shows your brain learns infinitely better when it already has a framework to build on. Taking just 2 to 5 minutes to preview the chapter primes your brain to capture new information so much more effectively. Look at the title, the headings, the diagrams, the summary. Ask yourself, what is this chapter trying to teach? What do I already know? What am I likely to learn here?
And while you're previewing, definitely do this. Utilize the Q in the famous SQ3R method. Survey, question, read, recite, review. This has been studied for decades. Look at how turning a boring heading into a question naturally forces your brain to search for answers as you read. Instead of passively reading the heading, the cell membrane, turn it into, what is the cell membrane? Why is it important? Suddenly, you aren't just reading, you're on a hunt for specific information.
Section 3, the Feynman technique. So you've prepared your brain, now let's explore how to actually process the text during your study session using small 1 to 3 page chunks.
Instead of reading 30 pages straight, which we know just overloads your working memory, read a small subsection and then stop. The crucial point here is that after reading that small section, you should immediately try to use the Feynman technique. This is an amazing method where you explain a complex concept in completely simple language, connecting it to what you already know. Picture yourself at a coffee shop trying to explain cellular biology to a friend or maybe a younger student who has absolutely no background in the subject. If you can't explain it simply in your own words, well, you probably don't understand it well enough yet. It's a brilliant, immediate diagnostic tool for your own comprehension.
And instead of copying entire paragraphs, which is highly inefficient, force your brain to process the information by taking minimal notes. Use keywords, draw diagrams, or map out flowcharts. Try tracking a cause and effect sequence, like for photosynthesis. Sunlight plus CO2 plus water leads to glucose and oxygen. You're mapping the logic rather than just transcribing words like a robot.
Section 4, active recall and spacing. Let's transition to the after phase of your study session. This section holds the absolute most important techniques for long-term retention.
I seriously cannot emphasize this enough. Active recall is the single biggest difference between effective and ineffective studying. It consistently outperforms rereading. After reading a section, literally close the book. Ask yourself, what did I just learn? Can I explain it? Try to recall everything from memory. You only reopen that book to fill in the gaps you missed. Retrieval strengthens your memory far more than additional reading ever could.
But here's the catch. Doing active recall just once isn't enough. Human memory fades incredibly quickly without review. To counter this, we use the spacing effect.
It's one of the most robust findings in all of learning science. This timeline brilliantly maps it out. Review the material on the same day, then 1 day later, then 3 to 7 days later, then 2 weeks later, and finally 1 month later. Spacing out your active recall locks the information deeply into your long-term memory.
And here's another fantastic technique for when you're scheduling those spaced sessions. Rather than studying biology for 4 straight hours, this chart visualizes interleaving. You mix related topics. You do biology for 45 minutes, switch to chemistry for 45, maybe physics for 45, and then do some biology practice questions. Interleaving totally improves your ability to distinguish between different concepts and apply them appropriately. It's a real game changer for problem solving.
Section 5, the 45-minute master plan. Okay, let's take all this abstract science and synthesize it into a highly actionable master plan.
First things first, you need full attention. Multitasking absolutely destroys comprehension. No checking your phone, and definitely no listening to lyrical podcasts. Your brain is a powerful engine, but it's terrible at juggling. Use the Pomodoro technique to maintain peak focus here. Dedicate 25 to 50 minutes of purely focused reading, followed immediately by a 5 to 10 minute break to let your brain rest.
And here is how you perfectly structure that block of time. First, preview for 5 minutes to activate that schema. Second, question for 2 minutes to really engage the brain. Third, read for 15 minutes, short sections only. Fourth, recall for 10 minutes, close the book and retrieve from memory. Fifth, check for 5 minutes to fix your mistakes. And finally, review for 8 minutes. Boom, a scientifically optimized 45-minute textbook session.
Listen, if you only take away 3 things from this entire explainer, these are the most consistently supported cognitive psychology methods you need to adopt today. The big 3. Number 1, active recall. Actually retrieve information from memory. Number 2, spaced repetition. Review material over increasing intervals. And number 3, elaboration. Use the Feynman technique to explain concepts in your own words.
I'll leave you with this provocative thought to challenge how you approach your next book or study session. Are you spending your time reading, or are you actually learning? Because as we've seen today, they are for sure not the same thing. I really hope you now have the tools to make every single minute count.